We're at gotomath.com. Let's click on the calculus. Go down to definite integration. Looks like we're doing 4.1 here. Whoa, what is that? Find out here in a minute. Find the definite integral. Round to 4 decimal places. I'm like, that doesn't seem like that's spelled right, but I guess it is. Integral. Alright, we got the integral going from 4 to 26, 27 over da da da. Let's write that down. You got that written down? Well, if you don't, you got a second chance here. So we got the integral. Whoa, man, look at that. That is, I wish I could do that every time. That's amazing. 4 to 26. I wish I could get my H2Mill to look like that on the actual web page there. So we have 27. I mean, I could if I wanted to import a picture, but forget it. And you got the square root of x under the radical here, x to the 7th dx. So we're going to need to rewrite this. We'll have to rewrite, get it out of that radical form. Take everything into the numerator. All right. So we're going to have, I'll tell you what, one step at a time. How's that? So we have x to the 7th, and it's all raised to the half power. Right, that's your radical. Dx. Now you multiply your exponents. We got plenty of time, right? I don't know. You might have a test in the morning. Who knows? Okay, so 27 over. So we have 7 times a half, which is 7 halves dx. Let's do this. Let's just continue this right up over here. How's that? So we have the integral 4/26. Now we're going to have 27. Go ahead and take that x to the 7 halves up into the numerator, so it becomes negative 7 halves dx. Now we can finally take the integral. So we have 27 x. Now we're going to add 1 to negative 7 halves. You know what? We'll do a little side work right here. How's that? So, it's kind of crazy, but believe it or not, a lot of people forget their fractions. I think they just learned too much calculus up to this point right here. So we want to put a 2 over 2. We're adding 1, remember, so we're going to add 1. So 2 over 2 is 1, right? So we have negative 7 plus 2 is negative 5. I don't do this every time, but I thought I would do it anyway. Negative 5 halves over negative 5 halves. And then, of course, we're going from 4 to 26. 4 to 26, okay? And now let's do this right here. Let's go ahead and rewrite this thing. So we're going to have, let's bring that negative out front. We're going to flip this fraction. So what happens here is this 2 gets multiplied by the 27, so that gives us 54, right? 40, 54, yeah. 54 over 5. And we got 4. And now what we can do is go ahead and plug our stuff in, and we're getting kind of running out of room here. So we have that negative 54 over 5. And so I'm going to go ahead and plug in the 26 here to the 5 halves. We've got a minus. Always start a parentheses here because of this minus. Helps us not to forget. Remember, we've got a minus here now. So we have 54, 5, over 4 to the 5 halves. Trying to squeeze all that in. Okay. And we're probably going to end up putting approximation symbols here. Approximate it. Alright, so I'll let you plug that into your calculator, or maybe you're one of those people that can do that in your head and get this answer. Whoa. Alright, I'm going to cheat. So I'm going to be getting, and I forgot, what are we rounding? 4 decimal places this time? You know, is there any rhyme or reason? 5, 4 decimal, 2 decimal places, whatever. I almost forgot what I got. I think it was a 0 point. We'll find out here in a minute. 3, 3, 4, 4, 4, 4, 4, 0.3344. Yeah, that's what I'm getting anyway. It's what you should have got. So let's point 0.3344. Okay, looks good. Alright, so you want to come on over, go to math.com, practice. Maybe I'll be there, maybe not. Leave a message, leave a math problem. Just say something positive. Alright, see you later. Bye.